In the previous recording, we conducted a holdout method, which is part of cross-validation techniques on our data, and we did some prediction, and we actually compared, we did not do prediction, we compared two models by using one of the measures, which is RMSE. We found that the second measure did better using holdout cross-validation technique. But the problem that holdout method has many shortcomings compared to the k-fold cross-validation. First, it tends to provide high variance in performance estimates. Why? As a single train test or train validate split can be sensitive to the specific instances chosen for training and validation. And the method, as we've seen, that depends on the randomness of the split. So making this sometimes optimistic or pessimistic about the model's generalization performance, because it depends on the randomness. We have two data sets randomly, so we don't know how this randomness will take you. Moreover, the holdout method utilize a limited portion of the data for either training or testing, if you are doing testing, in a single split. This reducing the efficiency of data utilization. So using part of this to do the training, part of your data. Finally, we did not notice this because we did not know yet, the holdout is sensitive to outliers, so it may not provide a robust, let's say, evaluation or assessment of the model performance. So what to do in this case? We are going to use more advanced technique, which is k-fold cross-validation. So on the other hand, the k-fold cross-validation address all of these issues by systematically cycling through different training sets and offering more stable and reliable estimate of the model's performance. So we are splitting the data into 4, 5, 6, it depends on the number of folds. Then we are doing the split and usage of all of the data to be trained. Then we leave one part out, and so on. We use the next 3 or 4. In this case, we have four-fold. So we divide into 4 folds. We use the first 3 as a training. We leave the last one. We use the last one as a validation. Then we redo this again using the first 2 with the fourth one. We leave the third one as a validation. Then we use the last 3. We leave the first one as a valid, and so on. So we are creating basically 4 models just by implementing the 4-fold cross-validation. That's why we're going to go for this now. Before we start, we are going to install packages. So we're going to install in the console packages the package called caret, and this caret depends on others. So we're going to use another argument called dependencies, because we are going to use two things here. So we're going to use two types of packages, depends and suggest, and we're going to run this because I have it, so I don't want to install packages. We have an error. Why we have an error? Install packages caret suggests. If you got an error, let me delete this. Let me delete this. Install caret and install another package called tidyverse. Tidyverse is not available. Oh, we have a B here. Delete the B. Tidyverse. So you have tidyverse. Yeah, there's no way that tidyverse disappear. After you install them, load them. So you have to install these. Again, if you remember, we talked about this. Installing the packages just occurs once. There's no need to redo this every time. Just every time you use them, you have to load them. So load the required libraries. So library caret without quotations. No. Tidyverse, then caret. So we have both of them now downloaded or given or loaded. Now let's build the model. I already have this here. We build the model. Because we built 2 models, we would like to compare them, so let's build 2 models. First of all, we're going to use something called train control. This is a function. This function contains settings for how the model should be trained and evaluated including the choice of resampling method, because every time we're gonna create 4 folds randomly. So randomly they will be create 4 different parts of the data. So my data, we have my data, remember we have 100 observations, we're gonna divide them into 4 folds, 25 each, randomly. To do this, a function called the train control is gonna do this for us. Let me pause and write this down. And I'm going to call this my control. This is similar to the sample function we did in a holdout method. This contains 2 arguments, the train control. The first one tells you the method that you're gonna use, which is the CV, cross-validation. The second argument, we have to have the number of folds. How many folds would you like to create? So the method CV, comma, how many folds? 4. So again, as I said, this is similar to what? To what we did in the sampling in the holdout. After that, we are going to create the linear model. So estimate the models, both of them. We said we're going to do the linear and we're going to do the quadratic. Linear model, I forgot to say something. If you are starting from scratch, let me do this here. Let me do something, because I'm starting from scratch for this video. I deleted everything. Let me clear everything and let me copy the data sets again, loading the data sets. So in a way that we are starting a new, where is it? Here. So first of all, we're gonna load the data sets. This is my data. Here we go. We create my control. It's a list. After that, we are going to build the models. Well, we're gonna use a function called the train. Train is a function. Okay. This train function contains many arguments. First argument is going to be the formula. What is the formula? Is the happiness. Someone's gonna say, do we need to memorize these? It's not about memorization, it's about knowing what you're gonna do, and it's about practicing. If you practice, conduct many projects, these will be in your mind every time. So you know cross-validation is something important, so you know that you're gonna do train every time. So happiness, this is my linear model. We're gonna do happiness. This is my formula for the age and income, in terms of age and income. Second argument contains my data, so I'm gonna type data equal my data. Third argument is going to be the method that I'm going to use in this estimate. We're gonna use linear model. So the method is going to be linear model, LM. After that, we're gonna decide what train control you're going to use, or what is the folds that you're gonna, how the data is divided, how the data is created. So this is a train control, TR control. TR control equals the one that we created. This is kind of the division or the partitions that we created. So let me make it simple again. The first argument is the formula. Second argument is the whole data. Third argument is the method that we're using, which is linear regression, linear model, right? The last argument contains what you're gonna do with your data. We're gonna create 4 folds, which is this one, my control. I'm going to repeat this. We're gonna create quad model. So I'm going to copy this so I do not repeat everything, but we have to be carefully dealing with this. But the happiness is written in terms of what? Income and age squared plus the log income. Do you remember this? Watch the videos about the quadratic term and semi-log first, then watch the holdout method, then watch this one. So now we are creating 2 estimates. So we have estimated 2 models, the linear model and the quad model. Next, we are going to evaluate the models. Very simple evaluations. L model, by the way, these models that we have built, just type L model, type $. Look how many things we're getting. We're getting so many things. We're getting results. We're getting best tune. We did not talk about this. Training data, p-type, pre-sample, method, model type. We have other stuff. It's a list. Contains many things. Contains data frames. Contains vectors. Contains variables. Contains so many stuff, right? But now we care about results only. For the linear model, for the quad model, run the results again. Oops, not resample. Here we go. This is the first model. What value we are looking for? RMSE. Someone's going to tell me how the cross validation, the k-fold, the 4 folds. For every fold, listen, for every fold, so for example, the first fold, R create takes 3 sets, put them together, becomes a training set. One set stays to be validation. Then what R does, it does everything we have done before, like do the training, build the model, then using the model to predict the validation, then find RMSE. It does everything we have done like in the holdout method, but it does it 4 times in this case. 4 times, not just once. So we got 4 times RMSE, we got 4 times R squared, we got 4 times all these measures. And what does finally give you? Give you the average of these RMSEs, the average of R squared, the average of ME. These are all performance measures. We'll be talking about these later. So for now, look at the first model, the linear model, and the second model. The second has lower RMSE. This is 8.5, second we have 6.7. If you'd like just to report the first two, let's try to do this. The first, this should be a data frame. So I've got the intercept. I don't care about intercept. Basically, there is no need for 2. 4C, 2, 3, 2, 3. This is subsetting. We're just reporting the first two values. RMSE is 8.5 for the second model, 6.7, which is lower. R squared, 47%. Second one, 67%, which is much higher, which is better. So the second model explains better, does better. So the prediction power is better for the model 2. So model 2, it confirms all of our findings, by the way, from the first recording, second recording, and this recording. Yeah. So let me copy this and write it here. So model 2 performs. Let me pause and write this. So model 2 do better than model 1, which is the quad model, does better than the quad model. So this is everything about cross-validation techniques. Yeah, thank you.